Welcome 8th grade. Today we're talking about multi-step equations, so get that homework sheet ready. And I know a bunch of you are probably super excited, just can't wait, just stomping your feet because we get to start doing math with a Meg again. And this might sound familiar to be undoing multi-step equations, but there are a couple tricks that we're going to throw at you this year that you need to be ready for. So make sure you rewatch examples that don't make sense or come in with questions, anything you might need to know more about. So here we go. I like to give you an explanation of why something makes sense before we just give a set of rules. So here it is. Why is it that when we're solving equations, we reverse the order of operations? Well, the order of operations is great for combining values or for putting values and numbers together when you know what they are. It tells you the order in which to simplify an expression. But if we're solving an equation, we're trying to kind of do the opposite process. We're saying this number is going to be used in some operations, but we don't know what the number is. We need to figure it out by going through the reverse process and seeing what that number was before all those operations were done. So that's kind of why we do the reverse order. Another way to visualize this, if you don't believe me that following a Meg is great, we'll look at this example. Here we have x has been doubled or multiplied, and it's also had something added to it. Now if you want to undo the multiplication first, you can. But what's going to happen is you're going to have to split this guy in half so that you can split this into even groups. And then you're going to have a fraction or a decimal value to perform your other steps with. And a lot of people don't like to work with fractions and decimals, so Omega is going to prevent that for us, which is convenient. So we're going to see how that works in a second. But for now, just take these notes for me. Multi-step equation solving notes. Gemma is great at combining values. She's great at simplifying expressions, putting things together. But a Meg is going to be wonderful at solving equations because we're undoing what's been done, like my relationship. But that's besides the point. So we're solving equations. If we're undoing operations, we're going to follow a Meg. She's going to tell us the order in which to undo them. The third note is the most important that I'm asking you to pick up from this video, and that's unwanted denominators can always be multiplied away. If you see a problem with a denominator that you don't like, just start multiplying that by that denominator on both sides always to maintain equality. But then it's just going to cancel out. It's going to fall away. So we're going to see what that looks like in examples 2 and 3. But again, example 1, I'm asking you to draw the picture of the scales and to also show me the algebra. So let's convert this into an algebraic equation. So I said, again, we have two x's. X has been doubled or multiplied by 2, and there's also been 3 added to it. And was it equal to? It's balancing with 12. So Omega is going to tell me that the first thing I want to undo is the addition. So I'll undo addition with the inverse operation by subtracting 3 from both sides. And when I subtract 3 from both sides, we're going to keep it equal by doing the same operation to both sides. It's going to be equal to 9. Now what does that look like on our picture? Well, what we did was we just said, hey, it's really easy just to take away these 3. Oh, see, Meg knows what she's talking about. Really easy to take away those 3. The next part is we need to divide it. We need to undo multiplication with the inverse operation, which is division. If you multiply something by 2, then divide it by 2, it kind of undoes itself, and we're just left with x. And we have to do the same thing to the opposite side. So 9 divided by 2 is going to be 4 1/2. 9 halves is 4 1/2, or 4 5/10. Those are all equivalent. So you should know that for me. And what does it look like here? Well, we just said, now that we're just about to find our answer, now let's split it into even groups. Okay, yeah, we're still going to have to take just half of this last guy to split them up evenly. We'll get rid of half of it. But the nice thing is that, you know what? It's just our answer. Now I just know we have a decimal as an answer or a fraction mixed number as an answer, and that's okay by me. Make sure you have the picture and the equation I just erased, so rewind if you need to. But next, let's go on to some other examples. So this first one is telling me that m over 3 minus 89 is equal to negative 75. So again, I'm going to follow a Meg and our 3-step equation solving process. So we're going to draw the scales of justice. We're going to say addition needs to be undone. We'll locate the variable. There's addition or subtraction. There's also multiplication or division. There's subtraction and division. I'm going to undo the subtraction first. Meg says so. Now you can think of this as, how do you undo subtraction of 89? By adding 89. Or even if you played add ops, you could say, how do you cancel out negative 89? Well, you cancel it out with positive 89. If we're going to add 89 to the left side, we need to do it to the right because that's maintaining equality. These cancel out. We have m over 3 as equal to, well, we have more positive tiles than negative, but they're different signs, so they're going to cancel out. We are going to have positive 14. The last step is to undo division by 3 by multiplying by 3. If we multiply both sides by 3, these cancel out, and we find out that m is just equal to 42. Hopefully that makes sense. Again, we just went through our equation solving steps, and we undid addition and subtraction before multiplication and division. Make sure you got that guy down, and we're going to move on to the next one. I'm going to give myself a little more space because this is what we call a twofer. I'm going to show you how to solve this in 2 different ways, but first I hope you're realizing that before we do anything else, I can look at this and see, this looks awful. 174 divided by g squared plus 4, that's a miserable denominator. I don't even want to think about a fraction that looks like this. Well, the great thing is I can always cancel out a denominator I don't like just by multiplying by it. Now you have to remember that we said that the division bar is a grouping symbol, so this is all grouped, but if I multiply the whole right side by g squared plus 4 and the whole left side by g squared plus 4, I'm multiplying them by the same thing. It's going to stay equal, but what's going to happen with that denominator on the right side? It's just going to cancel out. If we multiply by something and divide by something, even if it's multiple terms, even if it looks messy, it's just going to cancel out. So now we can say, oh, this looks a little bit better. We have g squared plus 4 in parentheses, which is important, times 6 is going to be equal to 174. Now I told you this was a twofer. There's 2 ways to solve this one, so I'm going to show you both, and I'm wondering if you can pick out what I'm going to do. First of all, what would a meg say? And what else do you just see there? When you see that number on the outside of the parentheses, what does it make you think of? Well, hopefully it makes you think of the distributive property. What we can do is we can distribute this 6 and say, hey, we're supposed to find this sum and then multiply by 6. But the distributive property says I can multiply the individual parts and then add them. I can multiply them both by 6, in which case we'd have 6 times g squared plus 6 times 4 is 24. Equals 174. A meg is going to say, okay, now you're ready to start undoing things. What are we going to undo first? Well, I want to undo addition and subtraction, so I'll subtract 24 from both sides. 174 minus 24 is going to be 150, which is a pretty nice number. We'll have 6 times g squared is, oh, that looks awful, sorry, is 150. Now what can I undo now? Well, there's an exponent to undo and there's multiplication. A meg says undo multiplication before the exponent. I have to divide both sides by 6. Now I get g squared is equal to 25. Now this should look nice. If I know that a number squared is equal to 25, hopefully you know what it is, but you can also think that to undo squaring, you can do square rooting. So g is going to be equal to the square root of 25, which is positive or negative 5. So this has 2 answers. Now let's solve it another quick way. I'm going to ask you to write down this process too, because I think a lot of you are going to like this more. I cannot tell you how often it is nice to distribute, but if you really don't want to distribute, you can say, I'm just going to start solving this equation. I'm going to follow a meg and see if she gets me to the same answer. Well, a meg says undo grouping last. So what's grouped with our variable is the exponent and the addition. So I've got to do those last. I'm going to undo the multiplication by 6 first. I can undo multiplication by 6 by dividing by 6. If I cancel those out, I just am left with g squared plus 4 is equal to 174 divided by 6. I'm just going to tell you right now that's 29. If you don't believe me, you can check it, but you should believe me. But you should also check it. Now that we've undid the grouping, we can say we have an exponent, we have addition to undo. Let's undo the addition first. Subtract 4 from both sides, and we'll have g squared is equal to 25. Oh, this looks familiar. G squared is equal to 25. Undo squaring with square rooting, and we have g is equal to positive or negative 5. In either way, the important things I want you to realize here is that to get rid of this big, ugly, bad denominator, we just multiply both sides by it. But you need to know that it needs to be grouped. The whole denominator expression, g squared plus 4 in this case, needs to be grouped because we're multiplying not just 6 times the 4. We're not just multiplying 6 times g squared. We're multiplying that whole left side times g squared plus 4. That's why it needs to be in parentheses. So make sure you have both those ways of solving it. I know this is taking a while, but that's it for the walkthroughs. I promise I left you some a little bit easier ones for you to do as your practice problems. So here they are. Practice number 1, 2m minus 37 equals negative 55. And number 2, 3 times the quantity of x squared plus 7 equals 96. I'll tell you right now, number 2 you can solve in 2 different ways. It is up to you. Just make sure you follow a Meg, and I'll see you later.